And now for the converse of the Pythagorean theorem. The Pythagorean theorem basically says if we have a right triangle with sides A, B, and C, then A squared plus B squared equals C squared. The converse goes the other way, and that is if A squared plus B squared equals C squared, then a triangle with those lengths, A, B, and C, is a right triangle. So the most interesting use of this is, and I referred to this in a previous video, how the ancient Egyptians measured right angles. And it is believed that they didn't know the full Pythagorean theorem, but they did know about the most beautiful of all right triangles, which is the 3, 4, 5 right triangle. A triangle with sides 3, 4, and 5, well, 3 squared plus 4 squared is 9 plus 16 is 25. That just happens to be 5 squared. And because the square of the 3 plus the square of the 4 is the square of the 5, that means that this is a right triangle. And I will tell you, if you see a Pythagorean theorem problem, if you see a right triangle on an SAT question or a GRE question or any sort of standardized test, pretty much 9 out of 9 times it's a 3, 4, 5 triangle. Maybe it's a 6, 8, 10 triangle. Maybe it's a 30, 40, 50 triangle. The trickiest one I ever saw was a 0.6, 0.8, 1.0 right triangle, or multiplying by 5, and it could be 15, 20, 25, but you might not be surprised, but they almost always use the same ratios. Anyway, the ancient Egyptians knew about this, and they knew that if they did everything with string, they had long strings that they would have knots at equal intervals, and they would measure lengths this way. Well, they knew that this would be just a loop of 3 plus 5, 8 plus 4 is 12 units. And what they would do is they would get a long loop of string, and they would subdivide it they would have 12 things like this. They would have a loop of string with 12 equal markings. And one person would hold over here, and then someone 1, 2, 3 away would hold that. These are pretty demented looking people. And then someone 4 steps along, 1, 2, 3, 4, would hold on that. And then the remaining people would be 1, 2, 3, 4, 5 apart. And they would all pull away at the same time, and when they pulled out, we have person A and person B and person C. When they would all pull back, you would have, well, from C to B would be 3 long, and from B to A would be 4 away, and then from A to C would be 5 away, and they would pull it tight, and this would be a perfect right angle every single time. And so that's how they would do it. They would pull a long rope, and they'd say, your family is entitled to a plot of mud that is 30 units by 20 units. And so they'd stretch out the rope, and they'd count out 30 knots, and then they would pull one of these loops to make a right angle, and then they would pull another rope in this direction till you had your 20 units, and then they would do it again, and they would get a 30 by 20 rectangle drawn in the mud, and they would say, start planting, because the Pharaoh's going to want all of his corn eventually. So this is just a cool thing. So the Pythagorean theorem not only tells you that a squared plus b squared is c squared, but if a squared plus b squared is going to be c squared, then you have a right triangle.